Hi, I'm Alex Elman. I'm a site reliability engineer for Indeed. And this is how Indeed delivers constant change safely. I have 3 goals tonight. I'd like to challenge the way that you might think about safety. I want to demonstrate the value of having thorough incident retrospectives. And I want to help you discover and cultivate the resilience that exists in your organization. And we know it exists because you should be having more incidents than you're having. And I help people get jobs. And I help people get jobs by ensuring that job seekers have the most up-to-date, constant access to find and apply to jobs. And when that doesn't happen, that job seeker can't take the next step in their career. And that can affect their career trajectory. And Indeed might not run life-saving systems, but we do run life-changing ones. So a little bit of an overview of what I'd like to talk about. I want to talk about what threatens our complex systems. There are 2 things that do this, and I'll go into those. Then I'll go into an incident narrative. This is something that happened to Indeed this summer that meant that job seekers couldn't find jobs. I'll go into the retrospective process. This is the process you carry out to find out what went wrong and to facilitate learning. I'll talk about what to look for in this process, the retrospective report that gets generated as an output of this process, and finally, the return on investment for such a thorough process. So something that threatens complex systems is change. Change is near constant, and change comes from things like deploys, pushing out new indexes. It could come from configuration management runs like Puppet. And this past summer, we saw a lot of incidents. I call it the summer of incidents. The Google outage. This affected things like Gmail, Google Drive, YouTube. This was caused by a network change meant for a single region that leaked out to other regions and reduced the network capacity. Then there was the Verizon BGP route link. This was caused by an optimized route announced by a small Pennsylvania provider, and a large swath of the internet went through all of their equipment. The Cloudflare HTTP/HTTPS outage. This was caused by a degenerate regular expression added to their IPS. That meant that a lot of their customers who host their sites with Cloudflare, their sites weren't available. And then the Indeed mobile jobs outage. This was caused by a simple translation of text, and I'll go into how that happened. Component failure. This is another threat to our systems. I like this picture of a hard drive because it demonstrates this in practice. It's a spinning disk of rust going 15,000 revolutions per minute with this mechanical read-write arm, very delicate piece of machinery that hovers nanometers above the surface. There are thousands of these in our infrastructure. These are going to fail. They're going to fail all the time, and we need to make sure that they don't threaten our systems when they do. So I want to set the stage for what happened. Why couldn't users click on jobs in our mobile app? Why did it take them back to the home page? Well, early indications that this was happening came from social media. Our monitoring wasn't sensitive enough to detect this. And it all started with this change. We make lots of translations to our site all the time. We offer our site in 28 languages, and there are tons of the site that need to be translated. This is our mobile SERP. It's a screenshot, and there's a little button called All Filters next to the pillboxes. And the All Filters text needed to be translated to Chinese. And this translation went out in a data artifact the same way we push out our job indexes, as Kathan talked about. But why did that change cause an outage? Well, there were earlier changes that we need to talk about to understand it. That artifact that contains the translations, well, that's built by Jenkins. Historically, it was built with Ant. And shortly before that incident, we switched to Gradle. Another change we made is that instead of having our translations get pushed out with the application deploys next to the code, it's better to do this out of band. So translations went out via artifacts. That was a new change that happened to mobile. That same translation change that broke production, that was safe in QA. Previous translation changes that day were safe, but this one wasn't. And to keep the artifacts from growing and growing and taking up disk space, we rotate them. So what happened was the translation artifact in an older version of the artifact pointed to a JavaScript file. That path became stale. It still pointed to the old file. When that file got cleaned off from a new publication of the translation, that's when clicking on jobs broke. So we weren't resilient or robust for this, and how do we understand where we went wrong? How do we understand how we can be safer? We do this by having retrospectives. Retrospectives, it's a forward-looking exercise where we learn about our systems and we learn about our people. And you can't go this thorough for all of your incidents. There just simply isn't enough resources. So what are some signals to actually trigger a retrospective? If you hear things like, I had no idea that this could even happen, that's signals of surprise or excitement to explain what happened. People have rich detail, and we want to extract that. If there are people asking a lot of questions, that means the systems are less understood than we thought. Another reason to learn about our systems. And if there was a lot of effort to recover, or a lot of new things done, like actions that were never taken before to recover, or teams that never collaborate, that rarely happens. We want to explore that. So what do we look for during a retrospective? Well, one thing we want to know is what are all the contributing factors that went into it? Kathan kind of touched on this. Because focusing on one cause, that's an easy trap to fall into. And the reason is that we want to find contributing factors is that root cause, that limits learning. It leaves important contributions completely unexplored. You might say, I don't do RCA, I do the 5 whys. What about that? Well, I'll demonstrate why that's problematic. So 5 whys analysis, for those who don't know, it's asking 5 why questions of increasing specificity until you reach some sort of insight or possible root cause. But if you turn on the lights, you'll see that there's a universe of other things that you're ignoring. And why 5 questions? That's such an arbitrary stopping point. There are other ways to do this kind of inquiry. You also might say, you're telling me not to do RCA, but RCA is literally my job. I do that all the time. But is what you're really doing exploring causal chains and doing a diagnosis? Because if causal analysis and diagnosis is what you're doing, if you're not stopping at one cause and saying that's it, then actually what you're doing is very valuable, so don't stop doing that. Another thing we want to look for during retrospectives is how to design for failure. So I really like this picture of a traffic light because it demonstrates this nicely. The old design of a traffic light is a single incandescent bulb behind a colored lens. That's a very brittle design because if that bulb fails, then this device, which is meant for safety, no longer operates. The new design of a traffic light, a newer design, has an array of LEDs where more components can fail and we're still inside our operating tolerance. This is robustness. So I really like this video because when the power went out in Manhattan for 74,000 customers, it took out the traffic lights at a lot of different intersections. And the designers of the safety of the traffic light didn't plan for this. And so James, this New Yorker, took it upon himself without anyone asking and directed traffic at this intersection in the Hell's Kitchen neighborhood for 45 minutes. This is a really good demonstration of resilience in practice. It emerges from the system without anyone expecting it. This is present in your organizations, and retrospectives, this helps you find it. So adaptability. This is the adaptive capacity that our systems have to absorb failure. And machines are better at adapting to the known unknowns because we program the machines. We conceive of these known unknowns. That's fault tolerance. Humans are better at adapting to the unknown unknowns. This is called resilience, and you have this already. So let's do it. Let's do the retrospective process. And I want to point out again that the overarching goal of this is to learn. But before we dive into the retrospective process, we have to do a couple things. Make sure that our systems actually did return to normalization. That's a top priority. Construct a timeline. This serves as the very first objective artifact used to drive the rest of the retrospective. And then we gather the rest of the artifacts and then identify stakeholders and roles, like the person to own the process and the person to do the debriefing. So when I say retrospective artifacts, what I mean are all the different pieces of evidence that were part of an incident, sort of like becoming a police officer or journalist or gathering testimony through debriefs. incident or application logs, graphs, the remaining threats, contributing factors. The key deliverable, you compile all of this into a retrospective report. And the process generally can follow like this. This is an example of a retrospective process, one that we find effective. It starts with resolution. Then you begin very quickly debriefing. You interview people involved, and you want to do this very quickly because memories fade. And then you want to synthesize and analyze all of the different artifacts discovered and found during the retrospective. That'll help you author a report that's delivered to your organization, and it should be widely read, and that'll drive meetings that teams have on their own to look at the report and add fault tolerance and carry out action items. So debriefing, this is going to be a new process for a lot of companies. And if you're just starting out, I really want to plug the Etsy Debriefing Facilitation Guide. They wrote a great PDF available online that will get you started. It can serve as a roadmap for how to start debriefing. And when you hold your very first debrief meeting, what you'll want is you'll want these roles kind of understood ahead of time. The debrief facilitators, they'll do the interviewing. The scribe that should record both audio and write down what people are saying. The incident owner, the person that probably was involved triaging the incident. Any incident participants that have a lot of context. The retrospective owner who will own this holistic process. And any subject matter or domain experts that can add color to the technical aspects of the interview. The agenda is very simple. It just starts out with someone taking the room through the timeline. This helps align people and primes memory, and then the interviewing starts. One by one, a series of questions are asked of each person, and at the end, there should be enough time to allow others in the room to ask questions as well. So you might wonder if you have to start hiring for this role. It's not a specialized role. If you're interviewing candidates, then you already have this in your wheelhouse. You've been honing these skills all along. You just want to make sure that they're impartial. People who are involved in the incident don't make good facilitators because they're biased. They should be curious. They should ask questions continuously. They should listen. You don't want to interrupt someone when they're giving a recollection because you might never get back there. Be respectful. It's really important to foster psychological safety when we're doing these, because when people don't feel safe, they're not going to tell you the truth, and they're going to misconstrue the past. We want to be thorough, to go broadly and deeply, tenacious, deflecting off-topic discussion for other venues, and then using shared language. So this just means that you don't have to be really technical, just sufficiently technical to understand the terms that people are using. And when you're debriefing and you're asking people questions and we want to evoke recollections, it's important to understand that we don't recall things with perfect detail. So if I were to ask you to draw a dollar bill from memory with as many details as possible, you would probably produce the drawing on the left. And then if I gave you a dollar bill, you're likely to produce something with more detail. And it's not because you have a bad memory, it's because the way we store things like this in our mind is not through taking a photographic picture. We're not like computers. We're just better at recognizing than we are recalling things. So if I showed you this picture of a dollar bill, there's a slight thing off about it, and you probably immediately know what that is, and that's because you recognize a dollar bill. You don't recall it. So in a similar way, as debrief facilitators, we want to set the stage to help people recognize the situation they were in, what they were doing, and what they were thinking. So asking questions like, what were you doing right before the incident happened? Who were you sitting next to? Even what did you have for lunch that day isn't out of the realm of an inappropriate question. And even showing them things like their bash history or graphs is a good way to kind of prime their memory. Other useful tips during debriefs, start these debriefs within 2 weeks. Memories fade very quickly. Sending out the questions to participants, the surface prompts that you want to ask can help too. And then it's really important that you assess the comfort level of people who are going to be interviewed. Some people don't like being interviewed in front of their colleagues. You can conduct one-on-ones with them, but they can still come. So incidents are opportunities in our organizations where incentives temporarily change. And what I mean by that is when we have these major incidents, we stop and we realize we're actually less safe than we thought we were just an hour ago. And when incentives change, then what becomes possible in an organization also changes. So we're allowed to be more thorough. We're allowed to pull people off projects, and we're allowed to really look at things more deeply than we usually can, so let's leverage that opportunity to do these. So after debriefing is done, we want to start to synthesize and analyze all of our artifacts. So this is an example of a completed contributing factors artifact from the mobile jobs incident I talked about earlier. Now this is not an exhaustive list, but this just shows you how it isn't just one cause that is the result of a lot of these incidents. And digging deep helps us understand our system so much more. Another useful thing to keep in mind when you're filling out this report and you're doing this analysis is to avoid counterfactuals. So what a counterfactual is, it's a kind of a way to misconstrue the past using all the hindsight that you have. It's a form of hindsight bias, and I see it all the time in retrospectives. So all these counterfactuals are ones that were pulled out of retrospectives I found on the internet. It should have been obvious from the errors. Well, it wasn't obvious at the time. Had such a prefix limit been in place, this would not have occurred. This is not a useful thing to say. What's more useful to say is that the prefix limit should prevent future incidents. It's a more useful thing to say than trying to misconstrue the past. And this was due to the engineer making the wrong decision regarding the process. Until we actually talk to that engineer and really interview them, how do we know that's the wrong decision? Pejoratives, another thing to avoid in retrospectives. Again, the only explanation we can conceive of is why this wasn't in place is sloppiness or laziness. This was from a retrospective that was published this summer. So what do we find in this retrospective analysis? We find things like automation surprises, how experts cooperate and share information, and the factors that led to accurate diagnoses. So this top scenario, this was the actual scenario mapped to kind of like a timeline where we go through these different processes from detection and diagnosis to alignment. Diagnosis was made by an engineer who actually saw this same type of thing before. They saw it in QA, they recognized the JavaScript error in their console when they reproduced it, and they quickly came to a diagnosis. They helped align people in Slack. It led to mitigation and restoration. If we can put together a mock scenario of the same incident, but we took that expert and put them on PTO, then someone else has to make that diagnosis. Maybe they don't have as much experience with this particular outage, so the diagnosis takes longer. And then mitigation takes longer. And now our restoration maybe happens minutes or hours or even days later. There's a tendency to compare incidents. So you might be experienced with initiatives like, let's all resolve to reduce our mean time to detect or mean time to resolve by 25% by Q4. It's tempting to do that, but you cannot compare incidents that way. Incidents are snowflakes. It's just as arbitrary to say, let's look at 2 car accidents that happened at different parts of New York, and let's try to improve on the mean time to respond. It's arbitrary. If we have to compare incidents to find value, compare a hypothetical version of the same incident to itself, controlling for a single variable like we just did. And our systems will never be truly understood. That's why it's important to assess the mental models that people have. Because experts have different mental models than others. And our mental models, they're things like system diagrams, their documentation, their design review output. So when we do these analyses, we want to look for the things that people are saying and doing during these incidents, cues that people are using to start making decisions, previous near misses where we almost had an incident but didn't, and to see what prevented it, and the things that we call common knowledge or common wisdom. How common are they really? And what's that one weird trick that one person does to narrowly avoid an incident, but they don't tell anyone that? Once you have this retrospective report, don't just file it away. Spread it as far as you can. Bug people about it. Encourage people to read it. When you're at lunch, ask, oh, hey, did you read that retrospective report? It's important that people read this because this is where learning happens. A retrospective report, an example of how you can kind of organize it is start with an executive summary. You should be able to get the gist of the report just by reading the summary. If you want to go deeper, the factual information and background, this is objective information that helps you navigate the analysis section. And it should be very clear how you went from the analysis section to the recommendations made by the authors. Then finally, the appendices, these are the raw artifacts that are attached so people can kind of come to their own conclusions as well. So this report, when it's delivered, it should kick off a whole host of meetings that teams should have. And it should be left to the teams how they want to do this. But now, armed with this report, they can align on it, and they can have an extremely productive discussion about what is it from the recommendations are we going to pull out and turn into action items? How are we going to prioritize these based on what I'm reading here? And what owners are we going to have own these things? Because these are important action items now that we've read these recommendations. And these can happen in perpetuity. And I want to dispel a myth that I encounter a lot. Safety can be measured by the number of accidents that occur. This simply is not true. They're way too complex for that. And complex systems, their cause and effect can only be understood in hindsight. Better, use SLOs and error budgets to measure safety deviance. Because trying to measure the number of accidents that occur as a measure of safety is flawed. You could be caught in a local minima, and you might think that whatever intervention that you did is helping, when really you're just a victim of outcome bias. So use SLOs and error budgets to measure deviance from the acknowledged safety boundary. And safety emerges through the work done to continuously achieve the SLOs that we set. So you might be looking at this new retrospective process and thinking about how you're going to implement it in your own organization, and you might be going, well, what's the ROI? What can I really point to show that this is working? Well, it takes time, and we get better at this as we go along. But some things you'll start to notice is information velocity is improving. Information's getting to parts of the organization that didn't before. You'll start to notice a change in the way reliability work and feature work balance each other out. You'll see these findings creeping into design reviews and daily feature work. Participation in retrospectives should naturally start to increase and then hit a nice steady state. And then the exposure to retrospective deliverables starts to go further and wider. And you might be talking to people in your organization that know about incidents that you weren't expecting. And then psychological safety, as a consequence, could actually get better too. So barriers and guardrails are the type of action items that constrain actions that typically can lead to safety. So, maybe someone did something that we're allowed to do something and it caused an incident, and we no longer want to allow that anymore. But a future incident, that very thing might actually come and save us. So I'm not saying don't have barriers and guardrails. All I'm saying is that just take care when using them and weigh the risks of implementing them. And I like this statistic. 92% of catastrophic failures involve incorrect error handling, like a 1 megabyte check. And all I really mean by this is the things that we add to our systems to make them safer, they can actually make it more dangerous. So how do we know what we're doing is making our systems safer? Well, we need to test it. We need to test and make sure that the robustness and resilience that we're adding isn't making things more dangerous. So we purposely inject known failure modes into our systems in QA, yes, and production, and we validate our hypothesis. And as a nice side effect, we could also discover things, insights we weren't even looking for along the way. So these are the key takeaways. Evolve into a learning organization. Locate contributing factors, don't do root cause analysis, consider the risks of barriers and guardrails, and cultivate resilience and build robustness. Acknowledge that people are part of the system and move your boundary to incorporate that. And finally, SLOs should be used to measure deviance. Thanks, everyone. If you enjoyed this talk and others like it, visit our engineering blog and hit /talks, and you'll see other talks that we gave in the past.